you see here that we have again some data set that we are using for creating a random forest algorithm, and assume that we have this set of data, few sets of data, where which is representing based on age, sex, blood pressure, cholesterol, whether there is a possibility of heart disease or not, whether you have or not. So either yes or no. So it's either, sorry, it's a binary classification problem clearly seen. So what we have done, we have basically taken this x and y as you know, and then same again same strength test split. So it is showing that 189 points we are choosing for training data and 81 point we are choosing for testing data. We are choosing this one based on this train size. So it's like 70% data is for training and 30% for testing. You can vary it based on your requirement in future. Then here the decision tree algorithm, you know, the class for the decision, sorry, the random forest algorithm will come, which is random forest classifier. I hope you can see this, right? Random forest classifier, which is under sklearn.ensemble package. Remember, I forgot to tell you that this type of learning is called ensemble learning. Why ensemble? Ensemble means actually together. This random forest classifier, you can see, has several parameters I have passed here. Just like what I was discussing, that max depth. So what is this max depth represents? It represents what should be the max depth of the decision tree of present in this random forests. Random forest. Similarly, the number of estimators, or actually there can be many more parameters present. Even you can remove all these parameters as well. So if you remove all the parameters, then what will happen? The random forest classifier algorithm will try to give the best result by changing the max depth and all. It's actually, remember, if you give the full freedom to these algorithms, this algorithm will always try to make the classification accuracy at its best. Okay. So the classification accuracy will come how? Will definitely come on the train data on which it is training, doing the training. But if you rigorously try for only highest accuracy with this training data, then again I'm telling you there will be a high chance for getting a overfitting. It means that you will see that it is very high, the accuracy is extremely high for training data, but not good for trace data. So giving a full freedom to the classifier for creating a best model is not very good option or good choice. To some extent, we must also have to restrict the model training, that you restrict here. You restrict up to some max depth, or you restrict with the number of features that you are selecting in the in a decision node or something like that, in this different way. And that is what we can put in this criteria as a criteria, I mean as a parameter here. So if you search the list of parameters you can pass in random forest classifier, it's lot of criteria are there. You can simply check them and you can try with different criteria to see how the training accuracy or the accuracy of the model that being created is varying. That you can check in your home. So maybe it will be a very good opportunity to to understand the effect of these different parameters on model training, which will be definitely useful in future. Anyway, so if I just just run this, you see it's running with this different criteria and it's done. Now if I see the classification score, it looks something like it's very bad actually. Random forest score is extremely bad, right? Because only 65.6% of but my intention is not to make it 90%, because I have to do many more things here. I'm just showing you here that how you can at least start writing the random forest algorithm, and in creating a random forest algorithm using these packages, and then by changing different parameters, you can simply check how you are getting the best one. Now obviously with this uh, score, if you see what will be the criteria, what will be the prediction, and based on that we can get a mean absolute error, which is 0.35. It's not very good definitely, because this error should be, say for example, 0.05 or something like that, then it was fine, but it is not very good really, right? So naturally, anyway, so this can be further improved with different parameters. So what you can do in your home as a homework, that you can try with different criterias, different presented, you can put those criterias here, sorry, not criteria, it's parameter values here, and check how good this model is behaving. So we can stop here regarding the decision tree, and next we have to move forward to the next algorithm again, which is support vector machine. So this support vector machine will be very much useful in future also. So let's see what it is.